Hi everyone, hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Relevel. So now, without wasting any time, we are quickly going to get started on our journey for understanding the CORDS rule. So let's take a brief idea first and a brief introduction first, and then we will actually move on to the real rules. Okay? So the idea is that E.F. Cord was basically a computer scientist who invented the relational model for database management. So earlier, I would say more popularly used model for designing databases for reverse network model. Okay, but by the time E.F. Cord, who was a computer scientist, introduced relational models, after that time itself, relational models became very popular. Until this time, relational models is the one we actually use and most frequently used all over the world. Now, based on relational model, the relational database was created, right? So first we tried to understand what relational model was, and once that understanding was clear, the relational databases actually came into picture. So for that, what actually happened was Cord proposed 13 rules, popularly known as Cord's 12 rules, okay, to test database or DBMS concepts against his relational model. So we have a database management system, right? It is already existing, right? But now we have to actually check whether that DBMS system is actually following all the rules and the constraints defined in relational model by Cord. Okay, so for that, basically Cord's 12 rules, as it is popularly called, is designed or is known or put into place. But remember, there are actually 13 rules. So the idea behind that is Cord's rule actually define what quality, okay, a DBMS actually requires in order to become relational database management system. So we have DBMS and we have RDBMS. DBMS is nothing but a database management system. Underlying, it could be using any models. It could be using a graph model, it could be using a network model, anything like that, right? But in order to become a relational database management system, right, relational, as we talk about everything working in terms of tables and relatedly, right? So in order for it to become from DBMS to RDBMS, what qualifying rules it should basically have, that's what Cord rules basically tell us. Okay, till now, remember, there is hardly any commercial product that follows all the 13 Cord rules. So the idea is there is a far difference between the reality and what we actually practically do. Okay, this is what theoretically we should do, and that is there is something what practically we actually do. So the reality is that any databases that is designed so far in the commercial world, hardly they follow all the 13 rules. Okay, so the thing is that the 13 rules which are actually designed, they are like more for an ideal world or more for an ideal scenario, right? In reality, it is very important to, or it is not at all necessarily possible to implement all the 13 Cord rules. Okay, so even Oracle, which is like a big organization working in the database management system since throughout and since the start, and they realized the need in the very start itself, even they only follow 8.5 out of 13 rules. Okay, so that's what the harsh reality is, right? You can make 12 rules, you can say that those are the ideal scenarios to make a DBMS to RDBMS, but the reality is, right, that even the best organizations who are working day and night designing database management systems also only follow 8.5. So just make sure that whatever rules we read, you take them all with a pinch of salt and then you understand all of them. Okay, so the Cord's 12 rules, as we call it, are as follows. So it's like 13 rules. Okay, so there are 13 rules, but they run from 0 to 12. Okay, so there's a rule 0 over here as well. Okay, that's what like basically defines the overall idea. Now what it basically says is, let me show you. So there are a total of 13 rules only, starting from 0, 1, 2, 3 till 12. Okay, but like since the number is 12 over here, so some like people usually call it 12 quad 12 rules as well. Okay, but remember the rules actually are 13. So let's go over each and every rule one by one. So the rule 0 says that this rule states that for any system to qualify as an RDBMS, it must be able to manage database entirely through the relational capabilities. Okay, so if you actually want to become RDBMS, it's not like, half of your database is based on relational model, half of your database is based on, let's say, network or graph model. Okay, it's not like that. Everything, if you are making RDBMS, everything in the database should be through tables, should be through schemas, should be through rows and columns, two-dimensional table itself. You cannot create a hybrid network and then call it RDBMS. Okay, if you have to make sure, you have to make it binary. Everything should be managed entirely through relational capabilities. That is what rule 0 is. Rule 1 is the information rule. Okay, it says that all information, including the metadata. Okay, you remember what metadata is, right? Metadata is data about data. Okay, when you try to store relationship between tables, when you try to understand what kind of attributes you have, right? Some information or the data about the data, okay, which you are storing to gain better insights about your databases, is what metadata is. So it says all the information, including the metadata, is to be represented as stored data in a cells of table. Okay, the rows and the columns have to be strictly unordered. So even if you are storing the actual data or if you are storing metadata, even metadata has to be stored in rows and columns concept, basically through tables. Okay, that means even the information which is not really used to derive, or which is actually not present in the database, it's just derived information, even that should be present as cells only in the tables. Okay, the second rule is guaranteed access. That means each unique piece of data, okay, all the atomic values, that means all the values in a certain cell, should be accessible by table name plus primary key plus attribute, row or column. Okay, for example, here let's say you have a very big table. Okay, and here also let's say you have a big table. Okay, I'm just like trying to represent the wideness and the vastness of the data set. Let's say I want to access this, right? That is what it says, that if in a database you want to access any atomic value, it should be accessed by the fact that if you know the table name, okay, if you know the attribute, right? Let's say this is age as an attribute, plus if you know the primary key, right? It should be able to help you point towards the cell. And that is true as well, right? If I want to, let's say, access this, so if I know in which table it is present, if I know using the primary key in which row it is present, and if I know the attribute, it will tell me which column it is present, I should be able to locate each and every data or every atomic value in my database. Okay, so that is what it says, that guaranteed access. It should not be that any piece of data that is present in the database is not accessible. Okay, that is not a valid scenario. It's more or less like a very big problem, right? You have stored some data, but that data is not accessible, right? There is no way you can reach that data. There is no way to define whether that data is present. So that is what rule 2 says, that it is not possible. Everything has to have the guaranteed access rule followed. Okay. Rule number 3 says systematic treatment of null. Okay, so null as a word can have several meanings. Okay, it means that the data is probably missing. Okay, let's say here if I put null. Okay, now this null could represent a lot of things. That means probably the value is missing there. I wanted to fill something, but I do not have it, so I added null. Okay, or maybe it doesn't require any value at all over here. Okay, let's say either, so there are multiple possibilities. Either I did not add any value, or either there was not supposed to be any value, okay, over there. Okay, so that kind of logic should be handled consistently. Okay, you should have a defined way, or your understanding for null should be correct and should be consistent at all places. Okay, it's not like here you have put a null, okay, because no value was required. Okay, here you put a null because no value was required. Here you put a null because you do not have the data, right? Sometimes the data is missing or the data is incomplete, so you put null because it is incomplete data. So this is inconsistency of understanding. Okay, here null means something else and here null means something else. That is what the rule says, that it should not happen. Okay, null should have a consistent meaning and should be used consistently all throughout the databases. Okay, also primary key, you remember, right? Primary key is something which uniquely identifies each and every record. Okay, and this we covered in the keys discussion as well, that primary key cannot be null. Okay, primary key is actually something which is uniquely identifying each and every row, and that value itself is kept null. Okay, that means that entire row becomes inaccessible. So you have to make sure that the primary keys are never null. Okay, over here. Okay, and if you are putting some expression, okay, if let's say you are doing some average or you are doing some summation or you are doing any kind of expression over null, remember the output should be null as well. Okay, and any expression done or null on null should actually give null as well, and that is what the rule says. Now try to, once you understand the rule now, then go back to the rule and go back to the name of the rule. It says systematic treatment of null. Null should have a consistent understanding all over the databases. Okay, now let's go to rule number 4. Now the rule number 4 says active online catalog. So database dictionary is, it's nothing but a catalog, right? Is the structured description of the complete database and it must be stored online. Okay, the catalog must be governed by some rules as the rest of the database, and the same query language should be used on catalog as used to query the database. Okay, so the thing is, you are designing databases. Now if it's a very large data set, what will happen after some time is that the amount of tables and the amount of columns also can increase in the data, right? It may be that you are actually storing 300 400 tables, right? And each table might have 20-30 columns, and it happens. It's a real life scenario. It can happen when you are storing such vast amount of data. So when you're storing that, it becomes equally important that you have a catalog. Okay, you have a dictionary of databases, okay, which actually tells you what all structure, right, you are using in your databases. It gives a detailed description of the complete database, and it must be stored online. Okay, it should be actively available and it must be stored online. And the catalog also should follow the same rules that we apply on the database. Okay, whatever rules are applicable on the database for which the catalog is created, the catalog should also follow the same rules. Okay, and the same query language that you actually use to query the databases should actually be used to query the catalog as well. Okay, so catalog is nothing but like a description of what exactly your database is, right? And what exactly description you have for each and every, let's say, table of the database. What structure and schema are you basically following? Okay, that is rule number 4, active online catalog. Remember, catalog, this is nothing but a database dictionary. Okay, then we have rule number 5. Okay, rule number 5 is a powerful and well structured language. Okay, so one well structured language must be there to provide access to all manners of must be there to provide all manners of access to the data stored in the database. For example, SQL. Okay, SQL stands for structured query language. Okay, so if the database allows access to the data without the use of this language, then it is a violation. Okay, I told you in the very start and in the very discussion of the intro to databases that if it's a database, right, you cannot actually just fetch information directly from the database. Okay, it is not possible. You need something of a layer in between, which is known as a query language. Okay, so in order to communicate your I would say request to the database. Let's say you have to fetch some information, you have to insert some record, you have to update some record, right? Or let's say you have to remove some record. Okay, if any of these operations needs to be performed, there is like a particular query language that is put into place. So you have to communicate your request in this query language itself, and then only the results are going to be given to you. There is no other way that is actually way to access the information. If your database is actually allowing access to the data without the use of this language, okay, let's say sometimes some kind of compromisation happened, and without even writing the query, without even using the language, you are able to get access to the information, then that is a violation of CORD rules. CORD rule says that this layer is strictly needs to exist between the user and the database. Okay, you should not be able to directly get access to the database, and that is what you have to ensure over here. Okay, that you have a well structured language, okay, and based on that you are allowing access, right, to all of these data that is present. And one of the examples for that is SQL. Okay, SQL stands for structural query language, which we will discuss also in the future videos. Okay, SQL will act as our layer in which we have to communicate our request in SQL language itself, and then only we will be able to access the data. Okay, so that's what the entire overall idea is, right? And if this is not followed, again, this is a violation. If any of the rules are not followed, then it's a violation on the CORD rules. All right, so in this video we will just cover the first 5 rules, and in the next video we will cover the rest of the rules which are followed in CORD or which are designed in CORD rules. Okay, so just to quickly revise on what we have done in this is, there are 13 rules known as CORD 12 rules, okay, which runs from 0 to 12, so hence 13 rules, okay, which was basically designed, right, by E.F. Codd, who was a computer scientist. He was actually the one who invented the entire relational model as well, okay. And if there is any database which is DBMS and it wants to convert or become RDBMS, it has to follow all the 12 CORD rules. But remember, the reality is, in even the best companies which actually work on making RDBMS, right, they actually also only follow 8.5 and not all 30. Okay, so every rule, like, there's a big difference between theory and practicality in this concept for E.F. Codd, but it's important to know how an ideal database should look like. So in this video we started our discussion with the first 6 rules, okay, starting from 0 to 5. Rule 0 says that if you have to make any database, right, as RDBMS, right, everything in that should be relational models, everything in it should be tables. Rule 1 says that if you have to store any data, right, even data and data about data also should be stored in tables itself, in the cells of the table. Okay. Rule 2 says that every cell in table, in the entire database, in every tables, in every row, in every column, each and every cell, each and every unique piece of data should be accessible first by their table name, which will tell you what the table is. Then you should be able to identify the row with the primary key, and then you should be able to identify the attribute, or like the particular column with the attribute name. So if these 3 things are there, it should be able for you to guaranteed get access to each and every data in the database. Third is systematic treatment of null. First of all, you should try using as less nulls as possible, and even if you are using, you should have the correct understanding all over the database for nulls. Null can mean that no value is actually required. Null could also mean that the data is missing over there. Okay, so it could have different understandings. So you have to make sure if you're using one understanding in a place, it is used consistently all other places as well. And another thing being that do not use primary keys in null, because primary key uniquely identify each and every row. So if you are putting primary key only as null, that row will never become accessible, and it kind of violates the rule number 2 itself. Fourth is active conline catalog. So the idea is that whatever databases you have in these days, no matter if it's a small or a big database, okay, you have to maintain a database dictionary kind of a stuff, which is known as catalog, which will tell you the detailed description of the complete database. Okay, what's the structure, what's the schema, what's the description, right, what all are you following in the database, and it must be stored online so that it's accessible. Okay, and whatever, when you're designing the catalog, same rules should be followed for the database as well as the catalog. Even for querying the catalog, you have to follow the same rules. Then the rule number 5 comes, which says that if it's a user and if it's a database, there has to be a layer of query language in between. No data should be accessible without the query language. If any data is accessible without the query language, it's a straight violation to a rule number 5. So you not only have to use a language, you have to use a powerful and a well structured language, so that all the operations, fetching, insertion, deletion, updation, all are done in an optimized way, in a well structured way, and it's easy to communicate your request through the query language as well. One of the languages for that is SQL, which we will also cover in the future classes and sessions. All right. So this concludes our session for the first 6 rules. We still have 7 rules left that we will cover in the next video. So stay tuned. Please make sure you revise these rules first and then you move on to the next one. The names of the rules are very well defined. It should give you a good idea about what exactly happens in that rules as well. Okay. So till then, keep practicing. Make sure you go through this topic. This is a little bit theoretical topic, so it will require some attention from your end. Okay.